Hi guys, welcome to Trigonometrics. I'll be looking at the Logit and Probit models using Stata. Earlier we focused on regression model where the dependent variable y is quantitative or contains continuous variable. And the question now we ask is, what if the dependent variable y is qualitative in nature? What if the dependent variable requires that there is a yes or no decision? Like for example, what if the dependent variable comprises of a person who is in labor force or a person who is not in labor force? How do we model those such variables? What if a person owns a car or a person who do not own a car? How do we get those data? And also, what about choice of votes for two political parties, for Democrats and also for Republican? And what is required now is that we assign values. We assign values 1 and 0. In this case, a person is in labor force, we assign 1, and the person who is not in labor force will be assigned 0. Also, a person who owns a car is assigned a value of 1, and a person who do not own a car is assigned a value of 0. And so when it comes to choices of votes for two political parties, if we decide to choose the Democrat, you can assign 1 to it, and decide to choose the other, the Republican, you can assign 0 to it. Now in this situation, earlier in a model where y is quantitative, our objective is to estimate its expected or mean value given the value of the regressors. Now in a model where y is qualitative, our objective is to find the probability of something happening, such as owning a house, voting for Democrats, belonging to a union, etc. Now these models are called binary response regression models. Binary response regression models, and there are 3 approaches to developing a probability model for a binary response variable. 3 approaches. One of them is the linear probability model. The second one is the Logit model. The third one is the Probit model. Now the linear probability model is just a typical linear regression model, but because y is binary, it's either you have a yes, that's 1, or a no, which is 0. Then it's called a linear probability model. And the ordinary least square can be used to estimate the linear probability model. But there are caveats. By logic, the probability value must lie between 0 and 1. However, the OLS does not take into account the restriction that the estimated probabilities must lie between 0 and 1. Also, the assumption that the error term is normally distributed cannot hold when a dependent variable takes only values of 0 and 1. An error term in the linear probability model is heteroscedastic, making the traditional significance test suspect. So for these reasons, the linear probability model is not the preferred choice for modeling binary models. We use the Logit and Probit models. Now, for Logit and Probit models, both of them are used to model binary response variables. The key difference lies in the underlying probability distribution. For Logit, the underlying probability distribution is the logistic distribution, and for Probit, the underlying probability distribution is the standard normal distribution. So for interpretation, the Logit uses the odds ratio while the Probit uses the change in disease score. And the Logit is mostly common in epidemiological studies, and while Probit is more common in social sciences. Now let's take an example. We have a binary response model where MD is a function of INC, it's a function of size, illness, and EDC, where MD is medical debt, as household and income healthcare debt, or not. We also have INC, which is equals to income. We have size, which equals to family size. We have illness, which equals to chronic illness, and then we have EDC, which is education. So what are the steps to take in estimating the model using the Logit and the Probit. The first one is to import Excel using Stata. Earlier we had posted a 3-minute video with respect to this, and then you click statistics, then you click binary outcomes, and if you're going for logistic regression, you click logistic regression. If you're going for Probit regression, you click Probit regression. The next step is to select dependent variable and independent variables, and then we click OK, and then we click submit. So let's see how this is done in Stata. Go to Stata, click on statistics, click on binary outcomes, and then click on logistic regression. Okay, this is a dependent variable MD. This is independent variable income, size, illness, and EDC. Okay, click on submit, and this is what we got for it. This is what we got: income, the odds ratio, size, illness, EDC, the constant. These are the probability values. Let's look at the expanded version of the PowerPoint. This is the exact result we've seen. The logistic regression, where the log likelihood is minus 101.67359, and then when we look at the odds ratio for income, the first variable, you see it has 0.580522 with a probability of 0.004, which is less than the 5% level of significance. And so what is the possible interpretation of that? For each 1 unit increase in income, the odds of having medical debt are multiplied by 0.58. And that was decreased by 42%, holding other variables constant. In other words, if households' income increases, the odds of having medical debt decreases by 42%. This is exactly what we expect economically. Higher income leads to lower medical debts. The relationship goes the negative direction and is significant. You can see 0.58 is less than 1. So it goes in negative direction. However, it is significant at the 5% level. So in summary, higher income provides strong protection against medical debt. That is that. Now, for that of size is not significant, and so we will not interpret that. We go for the next one, which is significant. The next one is illness. Chronic illness. Now, chronic illness has an odds ratio of 2.948351, which is significant at the 5% level of significance, the probability value of 0.002. Now, what are possible interpretations to this? Having a chronic illness multiplies the odds of medical death by 2.95. That increases odds by 195% compared to not having a chronic illness. In other words, households with chronic illness have almost triple the odds of medical deaths. This is exactly what's expected. Chronic illness leads to higher medical costs. Higher medical costs leads to more medical deaths. And you can see the relationship is positive because the value odds ratio 2.94 is greater than 1.0. So it's positive, and it is significant at the 5% level, 0.002. And what are possible implications of this? The affected households faces severe financial risks. And also these households are not protected by health insurance, and therefore they need special financial protection. Then what about education? Education, the probability value is 0.086, and though it's over the 5% level of significance, but it's less than at the 10% level of significance. And the odds ratio is 0.67. So let's see possible interpretations to that. Each 1 unit increase in education level multiplies the odds of medical deaths by 0.68. In other words, decreases odds by 32%, holding other variables constant. Each education level increase reduces medical death odds by about 1/3. So this aligns with what we know about education. The more education you have, it leads to higher income, which certainly leads to better insurance and leads to less medical deaths. So the fact that you are more educated, you have a better understanding of preventive care and how to navigate healthcare systems. So the next thing for us to look at the goodness of fit for Logit. Now we have the log likelihood, which tests for the overall model significance. and we'll look at the significant p-value of 0.000. It means that the model is better than the null model. And for the pseudo r-square, it is analogous to the OLS r-square. It gives the explanatory power and compares different specifications of models. But we should note that we should not expect the pseudo r-square to be as high as that of the OLS. So for this study, the pseudo r-square is 0.1547, which is a good explanatory power. We now go to the Probit. Before we go to the Probit, what we have to do now is to go to our Stata and see how the process is done for Probit. We click on statistics, we go to binary outcomes, we click on Probit regression. Okay, we have our dependent variables and independent variables. We click submit. Okay, so this is the Probit regression. Look, observe that it very well is almost similar to that of the Logit. So let's go back and see the expanded version of it. For Probit, say a 1 unit increase in income is associated with a 0.329 negative decrease in z-score of the probability of having medical debt. When we look at it, in order to make the Probit more interpretable, we calculate the average marginal effect, because here it has coefficient and not the odds ratio. So to make it much more interpretable, we use what we call the average marginal effect for the Probit models. Now, if you do not have the inbuilt function for the average marginal effect, but Stata has, that is why we use Stata for this lecture. Now, how do we carry out the average marginal effect? We use this command, margins, divide the x hash. So let us use that. Margins, divide the x hash. Enter. Good. That is it. We've gotten our average marginal effect. Let us see the expanded version of it. This is our average marginal effect. In this case, we can interpret it appropriately. For that of income, we say a 1 unit increase in income decreases the probability of having medical debt by 10.5% on average. You see, very easy. So for that of illness, which is significant, we have having a chronic illness increases the probability of medical debt by 20.7% on average. Very easy to interpret. Now for education, we also have each additional level of education decreases the probability of medical debt by 7.6% on average. So this is how easy it is to do a Probit analysis. In fact, I prefer the Probit because with the Probit, it's very easy for you to have an average or have the average marginal effect for variables, which is very useful. So thank you very much for this lecture. Bye bye.